Here's a quick demonstration on checking inverse functions. Look at the video description for a link to the companion document where you can find a link to this Desmos graph, as well as the inputs and the transcript. What I'm looking at here is a quadratic function that is graphed only where it is one-to-one and non-decreasing. I'm going to turn off all other inputs other than just f of x. That is the function x minus 2 quantity squared, where x is greater than or equal to 2. Without that restriction, we can see the full parabola. However, this will not be invertible, and that is because it is not one-to-one. And the graph of x equals f of y will show that. In that graph, you literally just reverse every x and y and plot the same collection of points with the inputs and outputs reversed. But here we see that we would not pass the vertical line test. We would have points with basically differing outputs depending on the input. And the reason for that is if we were to do the algebra here of reversing x and y and solving, we would find a plus or minus square root. So this is the positive square root up here. This is the negative square root down here. So that's not a function. Hence why we restrict the domain. Here, when x is greater than or equal to 2, our function is one-to-one and non-decreasing. Essentially, it's only increasing from its vertex up there. And now I can see the graph of x equals f of y is a perfect reflection across y equals x. That is the dashed line. And it is going to make a suitable inverse function. So when you set this equal to, let's say, x equals, and then y minus 2 in parentheses squared, then solve, we end up with an inverse function that is the square root of x plus 2. And you could kind of think about the story of x getting reversed. Here, x is reduced by 2, then squared. So if we were to undo those operations in order, we would square root and then add 2. So that's getting from the function to the inverse. And now I'll turn off the x equals f of y, and we see that is the exact same thing as our inverse. Whereas when I go back and remove the restriction, they will not match. Here I will see that the parabola, we need to cut that bottom half off. We need to get rid of that negative square root that we were seeing with that perfect reflection of the original. Here I'll put this restriction back on. And the very last graph here that I've put is f of g of x, essentially nesting the inverse into the function. And that just shows that these perfectly cancel out to the y equals x line, as long as we are with x greater than or equal to 0.